All right, everybody, welcome back to the second day of virtual classes. Hope the first day went all right for you. Before we get started, I do want to say that I am going to have office hours tomorrow. However, I'm not going to start right at 10 o'clock. I have an errand to run, need to pick up my lawnmower, and the pickup time is at 10 o'clock tomorrow morning. So I'm going to take care of that, get back as quick as I can, and then start office hours. It could be as late as 10:30. If I need to go a little bit past noon, I can do that as well. So let's go ahead and get started. Section 9.2, characteristics of quadratic functions. We're actually going to learn about three different things today. The first of which is called the zeros. The zeros are called that because it's where the value of the function is equal to 0. And by the value of the function, we mean the outputs. So the y values, or when f of x is equal to 0. So we want to know what x values make the y values equal to 0. When you have a quadratic function, you can have, and this sounds weird to say, you can have 0 zeros, you can have 1 0, or you can have 2 zeros. All right, we'll start with a 2. The way you have 2 zeros is you cross the x-axis twice. And it can be one that opens up as well. It doesn't matter whether it opens up or down. But right here, the y value is 0. So whatever those x values are, that would be the zeros of the function. You can have 1 0 if the vertex is on the x-axis. You only have 1 0 there. Or you can have no zeros, where it never crosses the x-axis. All right, so you can have 0, 1, or 2. Not 3, not 4, 0, 1, or 2. So these are pretty easy to find when you're given a graph. Little foreshadowing there. Eventually we'll find them without a graph, but not in this section. That'll be a later time. So if we look at this one on the left, and hopefully you guys can see that graph, but it crosses the x-axis at this point and at this point. So the zeros would be what the x values are there, which are -3 and +1. Here, the parabola crosses the x-axis at -2, so this only has 1 0, and that 0 is -2. The zeros and the x-intercepts are the same thing. We just refer to them differently depending on what context we're talking about. They actually have a third name. Sometimes they're referred to as the solutions, and again, we'll figure that out eventually, not this lesson. But if you find the x-intercepts, you have found the zeros. And just to over practice, I guess, we have 2 more. All right, this graph's a little bit weird. Your x-axis is actually up here at the top. So this one never crosses the x-axis, therefore it has no zeros. And here again, this one crosses twice, right there at the origin and right there when x is 4. So this has 2 zeros, 0 and 4. Definitely the easiest thing you're going to do today is look at a graph and tell what the zeros are. If you can identify the x-intercepts, then you've found the zeros as well. All right, let's move on to the second thing we're going to learn today, and that is the axis of symmetry. Now, if we look at a parabola, whether it's one that opens up or one that opens down, they're symmetrical via a vertical line, right? About a vertical line. So I can draw in a vertical line here, and we use the dashed line because it's technically not part of the graph. But a parabola would be symmetrical about that line. In other words, the right side is mirrored on the left side. Or if you were to be able to take this parabola and fold it along that vertical line, then this section would land right on top of this section over here. Okay, so this one would also have an axis of symmetry there. So it's the vertical line that cuts the parabola exactly in half. So we're going to learn how to find that axis of symmetry today. The first way we're going to find it is if we're given a graph. Again, this is terribly, terribly easy. So you look to see where that middle is, and if you find the vertex always lays on the axis of symmetry. Okay, so it makes a big shadow over. I can't see it, but it would be this line right here. That would be the axis of symmetry. Now, that is a line, so it's not a number for an answer, it's an equation for an answer. So the axis of symmetry would be x equals -1. That's the equation of that vertical line. If we look at this next one, we have the axis of symmetry here. X is equal to -2, so the axis of symmetry is the vertical line, x equals -2. So if we're given a graph, again, this is really easy to spot. Let's look at a couple more. Okay, again, you can find your vertex, or you can just sort of eyeball it and see, but this line that cuts it in half, maybe it's easier to do from bottom up, we get x equals 1. Over here, there's my vertex, so my line, x equals 2. So the axis of symmetry is simply this vertical line, which we draw as a dashed line because it's technically not part of the parabola, but so we draw it as a dashed line. A solid line would indicate it's part of the graph. And the answer is never a number, it's always an equation of x equals whatever that vertical line happens to be. So we're going to stay with the axis of symmetry, but instead of being given a graph, we're going to be given an equation. Now, anytime I give you a formula, I like to be able to show you where it comes from. I'm not going to be able to do that today, though. You're just going to have to trust me like this says. Right? It's not going to make any sense where it comes from. You'll just have to trust that it works. And at a later date, I'll show you where it comes from. We don't have enough background to be able to get into it today. But the equation of the line for the axis of symmetry is simply x equals -b over 2a. Now the b and the a are referring to your standard form of ax squared plus bx plus c. So -b is the opposite of that number over twice that number. Plug in -b over 2a and you'll get the axis of symmetry. So let's practice that. All right, we have the equation y equals 2x squared plus 4x minus 3, and we want to find the axis of symmetry. Well, a is equal to 2, and b is equal to 4. So x equals -b over 2a. Plug in our numbers. That would be -4 over 2 times 2, -4 over +4. We get x equals -1. So the axis of symmetry for that quadratic equation, for that parabola, is x equals -1. I have it graphed on the next slide so you can see that I'm not lying to you. So that's the same equation. This is what the actual graph looks like. Hopefully you can see the red line there. and it's going right through x equals negative 1. Okay, I have some for you to try. So the first one I would like you to try is y equals 3x squared plus 12x plus 8. So take a second, pause the video, and see if you can find the axis of symmetry. When you unpause it, I'll work through it. All right, we have a is equal to 3, and b would be equal to 12. So start with our formula, negative b over 2a. So that's going to be negative 12 over 2 times 3, which is negative 12 over 6. We'll get x is negative 2. So the axis of symmetry for this quadratic is x equals negative 2. And once again, here's the graph of it. So you can see there's the parabola, there's the origin, negative 1, negative 2, there's the red line, whose equation is x equals negative 2. Second one I'd like you to try on your own. We have y equals x squared plus 6x plus 5. So go ahead, pause the video, try to work this one on your own, and when you come back, I'll work through it with you. All right, so we have a Ninja 1 here. Oops, didn't draw. Right in front of the x squared. So we'll have a is 1 and b is 6. So the equation x equals negative b over 2a. We get negative 6 over 2 times 1, which is negative 6 over 2. X is negative 3. So the axis of symmetry for that parabola is x equals negative 3. And there's the graph again to prove it. So there's the origin, negative 1, negative 2, negative 3. All right, there's the graph of the parabola, and then the axis of symmetry going right through the middle of it. All right, here's the third thing we're going to learn. So the first thing was where what the zeros were. The second thing was the axis of symmetry. Now, we already know what the vertex is based on yesterday's lesson, but now we're going to learn how to find it when we're given an equation. So I mentioned this earlier, that if we have a parabola, the axis of symmetry goes through the vertex. Well, if we know the x value, let's just pretend this is x equals 3, that means every x value on this line is equal to 3, including this vertex. So if we know how to find the axis of symmetry, which we just learned how to do, that'll give us the x-coordinate for the vertex. To find the y-coordinate, you'll plug it back into the equation, solve for y, and we'll get the y-coordinate. So if we want to find the vertex, first find the axis of symmetry. That'll give us the x value, and then plug that x value into the equation. That'll give us the y value. Then we'll have both coordinates of the vertex. So I'll do one with you guys here. All right, we have y equals x squared minus 6x plus 2. So a is equal to 1 again, and b is equal to negative 6. The first time we've had a b value that's negative. So x equals negative b over 2a. So that's going to be negative b, which is negative 6. So we have two negatives there. One came from the equation, one came from the number, over 2 times, oops, I didn't mean to put a there, over 2 times 1. So that would be positive 6 over 2, which is 3. Okay, so that means the x value of our vertex is equal to 3. Now I'm going to take 3, plug it into the equation, and I'll solve for y, and that'll give me the y value. So I get y equals 3 squared, because it was x squared, minus 6 times 3 plus 2. Y equals 9 minus 18 plus 2. Y equals 9 minus 18 is negative 9. Negative 9 plus 2 is negative 7. So the vertex will be at 3, negative 7. All right, so again, first thing I did was find the vertex. That gave me the x value, because the equation of the line would be x equals 3, which means every x value on that line is 3, including the x value of our vertex. I plugged in 3 into the equation, solved for y, and that gave me the y coordinate for the vertex. Let me erase this and we'll look at the graph on the next slide. So there it is, y equals x squared plus, y equals x squared minus 6x plus 2. There's our parabola. Our vertex going through x equals 3, and hopefully you can see that. There's the vertex right there with the coordinates of 3, negative 7. Time for you to try one on your own. We have y equals negative 3x squared plus 6x plus 2. So find the vertex of that parabola for me. Go ahead and pause the video. Okay, hopefully you tried that on your own. Let's see if you got the answer right. A is negative 3, and B is positive 6. So when we plug that into the formula to find the axis of symmetry, I'm going to get negative 6 over 2 times negative 3, which would be negative 6 over negative 6, which is positive 1. All right, so far, for my vertex, I know the x-coordinate is positive 1. In order to find the y-coordinate, plug positive 1 into the equation and solve for y. So I get y equals negative 3 times 1 squared plus 6 times 1 plus 2. Square 1, you get 1. Negative 3 times 1 is negative 3. 6 times 1 is 6 plus 2. Negative 3 plus 6 is positive 3. 3 plus 2 is 5. So our y-coordinate is 5, which means our vertex is the point 1, 5. Okay, let me erase this and we'll take a look at the graph. Make sure I'm right. Okay. Remember from yesterday, A is negative, so you can see that parabola opens down. That's what the graph looks like. There's the origin, so go over 1. X equals 1, and there's the axis of symmetry. And then the point 1, 5 is the vertex. All right, the next one I'd like you to try on your own. We have y equals 1/4 x squared minus 2x minus 1. So go ahead and pause the video and see if you can find the vertex of this parabola. All right, this one had a fraction. Hopefully that didn't trip you up too much. We should be able to work through that. Let's see what we end up getting. A is 1/4 or 1/4, and B is -2. So we have x equals -b over 2a. That gives us our axis of symmetry. So -2, the negative of -2, I should say, over 2 times 1/4. So that's +2 over 1/2, which would be, when you divide by a fraction, you multiply by the reciprocal. Well, the reciprocal of 1/2 is 2 over 1, or 2, so we end up getting 4. So that means when we look at our vertex, the x-coordinate is 4. All right, we're going to plug 4 back into that equation. So y equals 1/4 of 4 squared minus 2 times 4 minus 1. I'm pretty limited on space, so I'm going to have to do some of this mentally, or else I'll run out of room. Square 4 and you get 16. Take 16 divided by 4 and you get 4. So all that simplifies to 4. Minus 8 minus 1. 4 minus 8 is -4. -4 minus 1 is -5. So our vertex should be 4, -5. Okay, let me go ahead and erase that. And we'll see if I got it right. Okay, there's our graph. It's kind of a little bit wider. We'll eventually learn why that is. The axis of symmetry, x equals 4. And the coordinates of the vertex are 4, -5. All right, hopefully that went pretty well for you guys. If you're confused on anything, or if you need some help with the homework, again, take advantage of office hours. I saw a few faces today, which was pretty nice to see some of you guys. Start to miss you after a while. So come on, ask questions, say hi, anything like that. Let's see, I think the next slide should be your homework. We have section 9.2, 3 through 10, and 13 through 16. All right, guys, I got a lot of people got their homework done today, which makes me feel good. We got to make sure we stay on top of this, keep up the good work, and I'll see you guys tomorrow.